Hello and welcome to Trustworthy AI De-risk Business Adoption of AI. Today we are joined with a very esteemed professional in the cybersecurity space, and her name is, you probably do know her already, but I will introduce her. Diana Kelley. She is CISO at Protect AI, and we are going to be talking about ML security lifecycle, machine learning life cycle, and how to the nuances and the obvious points for when it comes to security. Welcome, Diana.
Thanks so much for having me here, Pamela.
Now I'd love to kind of just start off with, if you want to do a quick intro and then talk about some of the differences and the challenges we are seeing in AI ML space.
Yeah, I started out my career in network security, and then I pretty quickly realized that no matter what I did up to layer three, it was layer seven that was going to be the problem. So I really pivoted and started focusing very much on application security, which of course led me to DevOps and the DevSecOps revolution. So I have a deep appreciation for what goes into a secure software development lifecycle and how we've had to optimize for the sort of modern delivery and our CI/CD pipelines with DevSecOps. So when I started then looking at AI and ML security, I started to realize that we've got an ML ops lifecycle. And just as we had to create touch points within the DevOps lifecycle to build security and weave it throughout the entire process and make it iterative, I started to realize that that was something that we were going to need to do in ML ops too. So started to really dive deep and try to understand what was the same. Because if you're a dev or DevSecOps professional, you have a rich set of experience and knowledge that actually applies into ML SecOps. So there's a lot of similarities because anytime that we're creating this process, that we're creating software that we're going to deploy, there are certain things that we need to do along the path. And then there's certainly some divergent points because creating traditional
Mhm.
software is not exactly the same as an ML lifecycle where you're going to be using models to analyze information, make predictions. It's a different approach. You know, a great example of that is at the beginning of a software development lifecycle, you have a bunch of people sit down, they create requirements, and this can happen in machine learning too. But one of the conversations that could happen in machine learning is, what could we do? Should we use machine learning for this? When you're writing software, it's, we want to sell tickets to this concert. So what does that application on the web need to do to sell the tickets to the concert? But with ML, it maybe we would love to understand how to improve this concert ticket offering by understanding when people buy or some other pattern recognition within that massive amounts of data. So there'd be a conversation and ideation of, is this a solution that we can apply ML to? Are we going to apply it in the right way? What sort of data are we going to need to train the model to ensure that it's going to give us answers that are going to be of value or useful to us? And that's the kind of thing that in a software development lifecycle, you often don't say what kind of data we need to train it. You talk about
Right.
the data that system is going to process. So similarities in that you still have a process that you follow. It is going to be an iterative process, just as in modern DevSecOps, but with nuances very specific to machine learning and also the people in the pipeline. Because now in machine learning, we've got machine learning engineers, we've got model risk officers, for example, we've got data scientists. So there are new players and stakeholders within the lifecycle as we look at ML versus traditional dev.
So clearly, there are a lot of differences. There may be some semblance of that fishbone, of development cycle, but that's where the similarity ends. Let me ask you this. You mentioned data,
Yeah.
right? That is something, when we are talking about creating secure SDLC in traditional systems, we did not have to worry too much about the data and what was, you could separate out production data from development data and developer access, right? Which is one of, I would say, one of the foundations of a good security model was that developers shouldn't have access to production data. How has that changed?
Yeah, isn't that funny? We for so many years fought this fight of, and it was hard because not having access to production data could really impact the training, or the testing of the software, because it's you testing it on data that was anonymized. And you remember we would have like format preserving tokenization, because there was this, we needed the data to make sure that we could handle the scale, but we couldn't use production data. We had to get some kind of test data for it, or at least tokenized or anonymized. um, and now what's interesting is that you need actual data. I mean, there will be training data, but it has to be
Right.
data that's going to be used to train the model. So it's not just a bunch of bits and bytes that are going to replicate it, what it would look like if I have a bunch of users on my system. We genuinely need to have active real data that we can train the systems on, so that they're going to have accurate outcomes. And that's a very different way of thinking of it, because as you said, traditionally my security mindset is just making sure that there's no live or production data in there, in the SDLC. But as we look at ML ops, you have to be very, that the data is used for the training. It's part of the outcome of that system, of how well that model is going to operate.
Yes, that, and also, what are your thoughts on, who are the developers now in in the new world of AI ML, right? Earlier it was software engineers, right? Now it's data scientists. Now is it a world that belongs to both, or and how? What do you see as the interaction?
I think it absolutely is going to belong to both. I mean, you're right. Like, as we look in the ML world, we have things like the model risk officer, we have machine learning engineers, if data scientists who are working in the Jupyter notebooks and analyzing the data and trying to figure out, is this something that is working the way that we need to or not? We need to tweak how we're training it, or tweak the data that we're training on. But it's still part of the software development lifecycle. Some people will say code is code, and kind of like, oh, it's all the same. It's not all the same. How we use it, how we develop is different in different use cases, and certainly there are some inflection points that are different between software development, standard DevOps, and ML SecOps. However, uh, machine learning and those models, they're running in systems that we already know. So it's not that we didn't invent a new way to have communications go over the internet. TCP/IP is still how that information is going to get passed. They're still running on operating systems.
Yeah.
They're running inside of our Kubernetes instances, for example. So we're still deploying it on a known software. And that creates this really interesting, I feel like ML SecOps is really like part of the bigger DevOps movement, because it's about the ML teams communicating with the DevSecOps teams to make sure that the software and the architectures that where the machine learning models are running are going to be fit for purpose and secure. So it's
Mhm.
really this whole layered set of work that needs to get done. But we have added these new folks, these new stakeholders into the conversation, like data scientists. And data scientists are absolutely brilliant at data science. They were not taught, most of them don't get taught application security, because they're busy
Okay.
learning data science. So I came across a piece a couple weeks ago that was it was a really interesting piece, in that it was written by somebody who's a part of a machine learning lifecycle, and was saying, hints and tips for best practices for data scientists not to store how to store information in Jupyter notebooks. And this article written a couple weeks ago had information in there, like, if you're storing sensitive information in your Jupyter notebook, and examples of sensitive information that could be API keys,
Mhm.
passwords, PII or PHI. So this article was helping the data scientists understand, if you're going to store something like that, encrypt it and make sure that the access to that notebook is protected and limited on a business need to know. Which, to for us security people, this is how we're like, if it's sensitive, of course you encrypt it. Don't store it if you don't need to. This is how we live and breathe. But of course, a data scientist doesn't necessarily think that way. So there's this whole group that we now have to have the conversation with. And once you explain to them why there's a risk, and why this could put data and expose sensitive data, they get it. but we have to have that conversation. We have to begin to educate the folks in the machine learning life cycle about these security considerations that for us in security may feel very much like that's, of course, we always do that. But we forget that everybody doesn't think with that mindset. So I think it's really about having empathy and conversation and communication so that those teams understand security impacts and potential risks. And one of the things that I think really helps to foster that communication, because especially because I'm an experiential learner, so I'm a little biased, is to
Mhm.
do threat modeling with those teams,
Right.
right? What could go wrong? What would, because anytime people go through threat modeling, they see it and they're like, oh, of course this makes sense. And once it makes sense to you, then you start to take those more secure actions. So it's really just about just having that conversation, helping people learn. And like I said, I think threat modeling is one great way to have that conversation and get everybody to get in the mix.
They're on the same page,
Yeah,
right? And I agree because sometimes this is not doesn't come natively, right? So
right.
it is not innate, right? It is we've seen this with security development teams for this battle,
Yeah,
right? Where how to securely develop code is you're going for developing functionality for meeting a business objective. You're not thinking about what could go wrong. But and so it's a similar, I find it's a similar environment where what we felt we had to do with educating developers in security. Now it is with developers as a security engineer as well as data scientists. I would combine the two in that category. But what you bring up is a very good point. Is not only having that conversation, but having a means to provide them, of how they can do it. And that is, of course, I know you with Protect AI, and you're offering a tool in that space, which I think is very much required in this field, because it's not just a question of having that right intention. If it's difficult to do, if you have to do three steps and you have, the project is supposed to have been delivered 10 days ago, you're not looking at those three steps. You're looking at how to go to minus three steps, not plus three steps. In other words, if you can make it easier, it is going to be more achievable. I totally am on board with that.
I agree. Yeah,
um
giving folks the tools and giving them access to that. And one of the things I like about Protect AI is that yes, we have a commercial tool, but we also have open source tools that teams
True,
can use
true.
right now, like NB Defense, which helps to it scans Jupyter notebooks for that sensitive information, and Model Scanner, which if you're using models, if you're downloading models from some of the better known models user model repositories, Hugging Face is one of the most well
Mhm.
known. It allows you to scan that model before you run it. And if so that if there's anything nasty in there, malicious code, you'll be able to see that before you run it. And that can really help a lot. But the other thing that comes to mind as you were talking, Pamela, is that you kind of touched on this point about resources for developers. And part of the movement as we were going SDLC to SSDLC, secure software development,
Right.
DevOps to DevSecOps. Part of it was actually a conversation that we had to have with executives and leaders. And that conversation was around giving the teams the time to get educated and rewarding them
Mhm.
for having secure and resilient software because the classic project management triangle, right, of better, faster, cheaper, right, and better if we replace that with more secure, more secure, faster, cheaper. You'll hear people say, oh, well, executives are always going to default out to faster, cheaper, but I don't think that's the case. I think that the executive is going to, default out to
I'm optimist.
what's the right thing for my business. So having that conversation with the leaders of organizations so that they can understand that training your data scientists and training your ML engineers on secure activities throughout the machine learning lifecycle is ultimately going to be a benefit to the company because you're going to have better performing models, you're going to have less risk and exposure for the organization.
Yeah, and that ties to the reason for this podcast, right? How do you identify what can be a roadblock, what can actually take away from what is your intended outcome, what can be a deterrent or a roadblock, or it can just make the project go south, right? How do you identify that and avoid that? So that's really important. And hey, by the way, I love the fact that you have both a free, open source, and a paid version of the. It's I think it's a extremely important thing to be able to not only want to do the right thing, but if you can do it easily, then it becomes more compelling. Absolutely.
Yeah,
So
agreed.
you made a great point about one thing that I want to kind of expand on a little bit about threat modeling, and you also talked about model risk officers, right? um, I think it's brilliant to bring that up because sometimes, as we talked about, developers or data scientists or whoever the stakeholders are focused more on what they have to produce and the functionality, not what can go wrong. But that doesn't mean that they don't know what that can be if you ask them that question. So posing that question, I think, is extremely important. Can you talk a little bit more about that? I'm really interested in your thoughts.
Yeah, I love that because what you're really getting at is that these are very smart people doing a really important job. Sometimes I haven't heard this so much in machine learning, but I do remember this back in early days of secure software development lifecycle, and it's just like the developers are just idiots. They just write bad code, and it's like, come on, they're not. They're trained professionals, that are doing a good job. It's just they may not have gotten the awareness of security. And I think it's exactly the same here. Right? Machine learning engineers, data scientists, they're brilliant people, but they may not have that security mindset. And I love how you were even saying it, it may not be native, right? It's not innate yet for them. But that's what threat modeling can really help bring out because all human beings are actually pretty good at risk. We forget how good we are at risk, but we make a
Right.
lot of risk decisions. We're pretty good. And I say pretty good because we're all very good at figuring out the risk of crossing the street now or waiting a couple seconds when the car gets closer, right? We go now. And
And not be on the phone and looking at your text while you do that
right,
now.
right. We go at the right speed. We can make that risk. Sometimes risk is if it because it feels really like personal. It can feel more intuitive. So a lot of people are more scared to get into an airplane than to get into a car, even though if you look just purely at the data, you're safer getting into the airplane. So
That's true.
right, so risk is this kind of funny thing. It's got this very personal element. We can also choose to accept risk or not. Again, that's another personal thing. And then there are some, how we interpret the numbers and understand and really be into to frame the true risk to us. And threat modeling is such a beautiful exercise for that because you bring in people, especially in ML, you bring in engineers and scientists that haven't thought about what can go wrong because most people are thinking about what can go right and how can we make it go more right and how can we make it go faster, right? They're like, what are these wonderful possibilities? And security, sometimes we get the bad rap of we're like, what's scary? But threat modeling is kind of this nice conversation where you say, okay, well, what can the downsides be? What could go wrong? And what you see is because these are very smart, capable people, as they start shifting their thinking a little bit into a threat model mindset, that they begin to become engaged in the process. And now they're the ones that are going to, start doing like mini threat models in their head as they're doing their work. So now rather than being like the folks that could expose data, right, they become your front lines and they're thinking through as I'm developing this new model, as I'm using this data, am I deploying it out? What might be something that could go wrong for the company? And is there a control or a way that I can, fix that or make that better and safer?
So I think that is these are all really really important things to know, right? When you are going into examining the world of ML life cycle.
Yeah.
Are there other caveats or nuances or extremely different things that people should be looking out for? Whether it's management, whether it's project manager or the developers. Yeah, if you could please expand on that.
Yeah, I would say really taking a much deeper dive and a closer look at the machine learning supply chain. So a lot of these
Mm,
foundational models that are available, they're open source. It's helping adoption and time to value go much more quickly. But making sure that you understand the provenance of that model, that you've scanned it before you run the model, for example. So that's one of the supply chain aspects. The data itself that you're using, making sure that it's not corrupt, that it's not biased. Models drift towards bias over time. So you want to be extra careful that you don't train a model with bias, because that's going to only automate and produce bias outcomes. Um, and then being able to understand the pieces of software that are associated with or running your models. So some of the most well-known pieces of software for running, for the pipeline, or like SageMaker, Databricks, ML Flow. ML Flow is an open source tool. Open source is wonderful for companies that want to, that may not have the money for commercial tools, or who really just want to support the open source community. There are some organizations that are very, 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 that's an important tenet of who that organization is. But these pieces of software, they can have vulnerabilities in them. One of our lead threat researchers at Protect AI found a vulnerability in ML Flow, for example, and it's been fixed. It's all taken care of, but it created it was a local file include, and it could have led to exposure. So taking a look at that, some of these tools, in some cases, the tools that we're running our ML models on are a little bit early in the security journey, is the best way I can say it. So, they may not understand fine grained access control or role based access control.
Right.
So, there's like one login for the entire organization. So the concept of least privilege hasn't been applied. So also in the supply chain, being careful of what you're using to run and develop your machine learning models, so that you've got a very robust chain. It's nothing here. If somebody who's listening to this and is going, that I'm a DevSecOps expert, and this doesn't sound that different. It's not entirely different. I mean, there are absolutely
Conceptually, it's not.
and differences. Yes, exactly. That we have to, like, we were talking about data, we were talking about the ideation phase, we're talking about software. When you put it out there, it quote degrades just because over time somebody might find a vulnerability, but the software itself, when it's running, isn't changing. Your model is learning all the time. It's dynamic by nature. So there are differences, but conceptually, if we think about a development life cycle that we put security touch points through, it's very similar. And the supply chain, right, keeping that supply chain safe and secure is also, that's the meta concept. And then when we get into the particulars of machine learning, we look at things like the model provenance, the data. And also another big component is the ability to manage the process. If we've deployed 100 models across our organization, and we find out that
Mm.
that model had something malicious in it, had code perhaps, and we have it used, or we're running it in multiple instances, or we've used the same data set to train multiple models, we find out that there was something flawed in that data set for whatever reason. Being
Mhm.
able to identify immediately all of the places where those models are running, and then potentially even using a policy to gate out that model and stop it from running. This can be really, really powerful, and it's something
Mm.
that we've got similar controls for a lot of the core servers or other workloads that we're using in organizations. That level of getting to that auditability, that governance, in ML is still maturing. So that's another really important part of the supply chain and of the management of the life cycle.
Wow, that's excellent to see how it all comes
Yeah.
together, right? I mean, cybersecurity is a piece in that, and how to, and it's a very complex and a really
Yeah.
difficult piece to get your hands around, or brain around, wrapped around. What I like to say is AI is a complex field, and cybersecurity is a complex field. You combine the two, it's really not a 2x, it's algorithmic, it's a logarithmic explosion, of complexity. So thank you so much. I really appreciate all your wonderful insights and practical, actionable insights, which makes it even more valuable in my book, because as we are looking at what are the challenges, it's really important to know how to solve for them. And thank you for providing that
Oh, thank you
today,
so
Diane.
much for the opportunity.
You're welcome. Thank you.